And this is our project Fun with Physics. I'm Morgan McCaffrey.
I'm Alex Burr.
And I'm Brian Godino.
Our initial goal with our BRG was to use an educational device for 9th and 10th graders. Throughout the process, we had various tests and evaluations that have confirmed our predicted initial evaluations and created a great educational device.
So at the beginning of the project, as a team, we decided what tasks needed to be accomplished throughout the course of this project. We then established the dependencies on each other and put them in a Gantt chart. The Gantt chart helped us stay on task during the project, and we were able to finish all tasks on time. So customer feedback is very important to the BRG's success. So we did a lot of potential customer interviews. And in these interviews, we kept seeing one interpreted need pop up a lot, and that need was the device needs to be entertaining. This is very important because the user needs to be engaged while using the product to learn the objectives well, and also it helps with the marketability of the BRG.
So from the customer needs, we developed product specifications, and this chart is of the QFD. It ranks each product specification to the complexity and how hard it would be for the team to develop that certain area. We have various levels of how it compiled and the complexity, and really much guided us on what we should focus on, what may not be realistic, and future goals that we should set for the BRG. So the patents are an important part of the product because according to lawsuits and such things like that, we don't want any patent infringement on any similar or identical ideas. This also is able to tell us what was similar to our product in order to help us either improve it, see what didn't work at all, or what we might want to try and just overall enhance our product.
So to develop possible ideas for our BRG, we first came up with a list of potential obstacles we might use, and then we associated a learning objective with the obstacle. Grouping the obstacles this way, we then put them into a concept combination chart, and we came up with several possible combinations for our BRG device. After this step, we put these potential concepts into a concept screening matrix. As you can see here, we had 5 concepts, and the concepts of the ramp and launch, spring trap, and ramp spring concepts passed the concept screening matrix. This allowed us to narrow our concept ideas down to just a few. After the concept screening matrix, we put them into a concept scoring matrix, which allowed us to identify one concept to pursue. It's important to note here our criteria and the weight of the criteria. Our highest weighted criteria were the understanding of learning objectives and the fun factor. The understanding of the learning objectives was weighted so high because that is paramount to the BRG success, as that is the BRG's ultimate goal, is to teach users concepts about physics and programming. And the fun factor was weighted just as high because the BRG needs to be fun and engaging for the user to want to continue to learn about these concepts. It also helps with the marketability of the product. A couple other highly weighted criteria were the ease of use and price point. The BRG needed to be easy to use because we didn't want users to get frustrated and then stop using the BRG. And the price point needed to be as low as possible so we could reach as many customers as possible. So the risk priority number, or RPN scores, from the previously analyzed obstacles have all improved. Now, we improved the RPN scores of each obstacle, keeping trade-offs in mind. For example, the spring launch ball obstacle was not improved at all because we felt that the trade-offs were too large to improve it. We also felt that the RPN score was low enough for it to remain the way it was. We would have to increase the budget greatly to improve the RPN any considerable amount. But the target ramp, mousetrap button, and Arduino were all improved with minimal trade-offs. Also, we added another obstacle in this FEMA chart, and that is the Ramp Cup launcher obstacle. And initially it had a high RPN score, so the team focused their efforts on improving this obstacle for the final product.
We created a decomposition diagram in order to trace the flow of energy and the flow of the physical material through the BRG, as well as the signals associated with the energy or the material flow. And so as the ball works its way through the BRG, we simultaneously keep track of the energy associated with each obstacle. And once it reaches the end of the BRG, it hits a target, which begins the phase where signals are introduced. Because once the button is pressed, it turns on the LED, which was programmed using the Arduino software. And for the product architecture, we decided to section off the BRG into chunks based not only on function but also physical proximity. And so obstacle 1 and 2 are really two solid chunks that are mostly pieces themselves that will fit into the board. But once we get to the third obstacle, it becomes more complicated, and so we had separate chunks for the catcher and the mousetrap, as well as the Arduino and its components. And the last chunk for obstacle 3 was the user input chunk, which is just the computer and the Arduino software which they're editing as part of their learning objective. And dividing into chunks in this manner allowed us to consider bus modular architecture if we were to go further with the BRG, because you could introduce different obstacles with different learning objectives and put them into the same board because it features slots that could be universal.
So one of the main things that helped us progress through our BRG were customer surveys. We had almost 60 responses, and one of the most important questions we felt was if the customer would simply buy the product or not. 53% said that they maybe would, while 12% said definitely. If we add those two, we have 65%. And although some customers may say one thing and do another, our realistic expectation of that percentage is around 50. So about 50% of the people that either hear or see our product or may interact with it are likely to buy it. This number seemed very well compared to other products, and how this number could also be improved upon either the design, the outreach, or simply the information on the product. As I said, multiple questions were asked in the survey, but we focused on this one.